Now let us discuss the derivatives of arc length. First let us know how to derive the derivative of arc length. Now let us consider a curve C in the xy plane. Let A be a fixed point on the curve. Let P be any point, variable point on the curve C. So let the arc length or the distance between A and P measured along the curve C be equal to S. Draw a tangent to the curve at point P which meets the x-axis at point T. So PT be the tangent drawn to the curve at point P. So this tangent makes an angle psi with the x-axis. Now we represent this point P using the coordinates S and psi, which are called as the intrinsic coordinates. So the coordinates of point P can also be represented by the coordinates S and psi, which are called as the intrinsic coordinates. So let us consider a point Q in the neighborhood of point P. That means consider a point Q very much closer to point P. Let the arc length between P and Q measured along the curve be equal to delta S. Let delta C be the chord, length of the chord PQ. So it is the length of the chord PQ. So now from the figure it is clear that as Q tends to P, delta S becomes equal to delta C. As Q tends to P, delta S is equal to delta C, and hence we can take delta S equal to delta C as the limiting case of Q tending to P along the curve C. Then we get limit Q tending to P of delta S by delta C is equal to 1. So this is the derivative of the arc length with respect to the chord C. So that is equal to 1.